This is the coasting to a stop problem that was assigned over the weekend. So it first asks us to construct a work energy bar chart for the problem. We know that it is initially moving at 20 meters per second, so we know that there is KE at 0.1. Then it says an 800 Newton friction force opposes its motion. Since we know that friction is always negative, it's going to be below the bar. We also know that at 0.1, the car is on a hill, so we know that there is GPE. And there is no spring constant. Then the question asks, how far will it travel before coming to a stop? Since we know that it's stopping, we know that KE equals 0. Assuming that that is the point where it stops, we know that H equals 0. Since H equals 0, we know that there is no GPE, no KE, and also no spring constant. However, all the friction that was in the beginning at 0.1 is converted to friction at 0.2. In part B, the question now asks us to use the work energy bar chart to construct a work energy equation for the process. So we always start with E1 plus W equals E2. We know that at 0.1 there is KE and GPE plus the work done by friction, which is negative, is equal to 0, since there is no energy at 0.2. We know that the equation for KE is 1/2 mv squared, and GPE is mgh. And we know that the work done by friction can be rewritten to force of friction times the distance equals 0. In the problem, we are given our mass, the initial velocity. We know that g equals 10 meters per second, and we're trying to find the unknown distance of d. The only variable that we don't know is h, and that can be rewritten using trigonometry. So that now equals sine theta equals h over d, which can also be rewritten as d sine theta equals h. Now that we know h in terms of d, we can rewrite the equation as 1/2 mv squared plus mgd sine theta minus force of friction times the distance equals 0. Now to plug in the values, we know that the mass is 1,500 kilograms. The initial velocity is 20 meters per second. and that gravity is 10, and sine (20) minus the force of friction, which is 800, and we're also still trying to find the distance equals to 0. Now, to move this to one side, we have 300,000 equals negative 277D. And when we divide 300,000 by 277, we get D equals 1,083 meters. And that is the answer to the unknown distance the car travels before stopping.